Today, I'm going to show you how to use these 4 resistors in under 4 minutes. Let's get started. This is a fixed resistor. It has a fixed amount of resistance. To check that resistance, we look at these 5 colors, and then look at this chart to calculate how much resistance it has. Or you can just use this calculator. It makes life way easier. And if you're wondering what happens when you don't use a resistor, yeah. The LED was not happy with that one. And yes, I did have to break my LED for this, so please subscribe, it really helps me out. So let's do this the safe way. In this setup, I'm using a 100 ohm resistor because I have a 5 volt power supply, and it lights up perfectly fine. But now, I'm going to swap it out with a 2000 ohm resistor. And as you can see, it is not as bright because there's less energy going to it because there's more resistance. This is a photoresistor. It's a tiny part that lets power pass through when it's bright, but adds more resistance the darker it gets. If you've never seen one of these before, think again. It's actually the main component inside those automatic night lights. It's how they see the room, if it's bright or dark, so they know exactly when to turn the light on. So, what happens when we plug it into our circuit? Well, we know that when it gets darker, there's more resistance. And as you can see, it does get darker because there's more resistance. And when my hand is not covering it, there's less resistance because there's more light. This is a thermistor. It outputs a certain amount of resistance based on how much heat it can feel. Thermistors are often rated for very high temperatures, going up to almost 375 degrees Fahrenheit. Here, I'm holding my hot glue gun on the thermistor for nearly a whole minute, and it still doesn't get hot enough for the thermistor to actually pass more electricity through. And you might be asking yourself, is the light even getting brighter? And yes, it actually is, but the difference is very, very subtle. This is the before, and this is the after. Now, sadly, I don't have anything hotter in my house to heat this up with, other than my oven, but hopefully you get the idea from this. This is a potentiometer, and it's probably one of the hardest resistors to understand because there's so many different ways to use it. The left pin is your input power, the middle pin is basically your output, and the third pin on the right is your ground. The 3-pin setup uses all 3 pins to lock full power on one side and ground on the other, creating a smooth electrical scale from 100 to 0% inside the track in the potentiometer. This allows the computer to read the exact position in the middle pin as it slides along the scale. It's just like a video game controller, measuring the exact voltage so you know how far you're pushing the joystick. But for a 2-pin setup, you can use the simple input as your left pin and output as your middle pin. And this allows you to do simple things like controlling the brightness of an LED. This is a simple circuit where I have its respective inputs and outputs, and I connect it over to an LED, and I still add a resistor just to be safe. And as you can see, when I connect the LED and twist the potentiometer, this 2-pin setup makes it so the LED brightens and dims. I have a short posted on my channel where I explain this wiring diagram in more detail and how you can do it yourself, so go check it out. Thank you for watching, and make sure you subscribe to Anthem Engineering.